Welcome to Two Projects. In this video, we are going to explain segmentation and classification of COVID-19 CT images using deep learning paradigm. Introduction. Coronavirus disease 2019, which is COVID-19, caused by severe acute respiratory syndrome coronavirus 2, is a highly contagious disease that wiped out millions of lives worldwide. The images of chest X-ray and computed tomography are extensively employed to provide a quick and reliable diagnosis of COVID-19. Manual diagnosis of the infection by radio images, on the other hand, is extremely difficult because it's time-consuming and prone to human error. Artificial intelligence, which are AI techniques, have showed promise and are being developed further in the creation of automated and accurate COVID-19 detection tools. Deep learning methods, particularly convolutional neural network, UNet, ResNet and Inception v3, have gained substantial favor among AI approaches for COVID-19 classification. Coming to objective, the primary goal of the project is to detect COVID-19 using AI-based medical picture analysis. Convolutional neural network, which are CNN, UNet and ResNet models, are trained to segment and classify COVID-19 impacted regions in chest X-ray and CT scans. COVID-19 classification is carried out by using Inception v3 architecture. The project uses dice similarity to measure segmentation accuracy and displays resulted via accuracy and loss graphs. The project intends to increase medical diagnosis accuracy and speed by incorporating deep learning techniques, assisting in efficient COVID-19 detection and contributing to better healthcare decision making. These are the requirements for execution of the project. In hardware requirements, operating system of Windows, processor of 5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. In software requirements, Python IDE of 3.7 version is needed. These are the algorithms used in the project. First one is convolutional neural network. CNNs are fundamental deep learning architecture for image analysis tasks. In this project, CNNs are used primarily for COVID-19 classification. CNNs excel at capturing intricate features in images, which is crucial for distinguishing COVID-19 positive and negative cases based on visual patterns. Next one is UNet. UNet is a popular architecture for image segmentation tasks. It is particularly suited for generating masks that identify specific regions for interest within images. UNet, designed with an contracting and expanding path, enables it to capture detailed information while maintaining spatial accuracy. In this project, UNet is used for segmenting COVID-19 affected regions in medical images. Third model is ResNet, which is residual network. ResNet is a deep learning neural network architecture known for its ability to mitigate the vanishing gradient problem in very deep networks. It is widely used for both classification and segmentation tasks due to its impressive performance. In this project, ResNet is employed for image segmentation to accurately identify COVID-19 affected areas. Fourth algorithm is Inception v3. Inception v3 is another powerful architecture for image classification. In distinguishing feature, it uses multiple convolutional filter sizes in parallel, enabling it to capture features at various scales. In this project, Inception v3 is used for COVID-19 classification based on segmented images. Coming to methodology, we have designed these modules. First one is Generate and Load UNet model. This module involves creating and loading a UNet model. UNet is a deep learning architecture used for image segmentation. This module sets up the foundation for performing image segmentation on medical images to identify COVID-19 affected regions. Second one is image segmentation. After loading the UNet model, this module performs the image segmentation on CT scan images to identify the regions that are affected by COVID-19. The UNet model generates masks that highlight these regions, adding visualization the extent of infection within the images. Third one is Generate and Load ResNet model. Similar to UNet model, this step involves creating, loading a ResNet model. Fourth one is COVID classification. This module focuses on classifying the medical images into COVID-19, which are positive or negative cases. The Inception v3 model is used for this classification task. Fifth one is CNN and Inception v3 classification accuracy and loss graph. This module generates graphs that display the accuracy and loss trends during the training of CNN and Inception v3 models for COVID-19 classification. Sixth module is UNet and ResNet accuracy graph. Similar to the previous module, this one generates the accuracy graphs. However, these graphs showcase the accuracy of UNet and ResNet models during their training or image segmentation. Coming to execution, we need to open the code folder. This is the code folder of the project and this is the dataset file. These are the mass datasets. These are the images. And this is the train images. On these images, we will be training the algorithms. And this is the ground truth images. For this, we will be testing. And this is the model file. This file contains .h5 files, pickle files, and JSON files. These contain the algorithm information, and these will be loaded into the project code during the runtime to utilize the train models. And this is the ResNet model, which contains the .h5, pickle files, and JSON files, which will be loaded into the project code during runtime. And these are the seg model files. These contain pickle files and .h5 files. This will be loaded into the project code during the runtime, and this will be containing algorithm information. And these are the test images. For this images, we will be predicting whether they have the COVID positive or negative. And these are the train dataset. And these are the Python main code files. And this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. So we need to double click on it for execution. This is the graphical user interface of the project. With this, we can interact with the program, and this is created by using tkinter library in the Python. So first we need to load the models. For that, we need to click on the button generate and load unit model to generate unit model. Here we can see that a unit segmentation model is loaded. Now we need to click on the button image segmentation to segment the image. So here we'll select this image and click on open. Here images are segmented. This is the CT original image, which is CT scan image, and this is the ground truth, and this is the unit segmented image. Now we will close this. Now we'll click on the button generate and load ResNet model to load the ResNet model. Here ResNet model is loaded. Now we can see this is the original image, this is the ground truth image, this is the unit segmented image, and this is the ResNet segmented image. By closing this, here we got the similarity, which is dissimilarity of unit and ResNet algorithm. Now we will click on the button COVID classification to detect whether the person has COVID or not. So this person is detected with the COVID disease. We can detect by the chest X-ray image. Now we will check with other images also. We will check with this image and click on open. Here, this is the original image, this is the ground truth image, and this is the unit segmented image. Now we will check with the ResNet image also. Here, this is the original image, this is the ground truth, this is unit segmented image, and this is ResNet segmented image. Now we will check with the COVID classification button. Here, this X-ray is also detected that COVID disease is there. Now we will click on the button CNN and Inception v3 classification accuracy. Here, infected detection accuracy is this much. So we will click on this button. Here on the x-axis we have epoch and y-axis we have accuracy and the loss. Green is the CNN accuracy, blue is the CNN loss, red is the Inception v3 loss, and orange is Inception v3 accuracy. Among both the algorithms, accuracy for every increase in epoch it is increasing, and for loss it is decreasing. Now we will click on the button unit and ResNet accuracy graph. Here we can see CNN accuracy loss, Inception v3 accuracy, and Inception v3 loss. Here by clicking on the button unit versus ResNet accuracy comparison graph, on x-axis we have the epoch and on y-axis we have the accuracy. For every increase in epoch, both algorithms accuracy is being increased. But among both the algorithms, unit accuracy is higher than the ResNet accuracy. So close this GUI. Conclusion. Finally, the project successfully exhibited the potential of deep learning approaches in automating COVID-19 identification from medical photos. The project provides accurate segmentation and classification of COVID-19 impacted regions by applying convolutional neural network, unit, ResNet, and Inception v3 models. Medical practitioners benefit from the created segmentation mask and classification output, which allow for faster and more accurate diagnosis. The evaluation metrics and performance graphs created for the project demonstrates that effectiveness of the proposed models. Finally, this effort emphasizes the need of artificial intelligence-driven solutions in complementing medical diagnosis process, particularly in the context of highly contagious diseases like COVID-19.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.